Hello everyone, today we're going to be looking at Quantipus number 17, another brain teaser. Definitely a very hard one to visualize, but we're trying to pack 53 bricks of dimensions 1 by 1 by 4 into a 6 by 6 by 6 box. This one is very similar to Quantipus number 15, which we were looking at the chessboard. It's the same principles and we're going to use the exact same trick. So for starters, a 6 by 6 by 6 box can hold a volume of 6 cubed, obviously, which is 216. And for each of these bricks, well, their dimensions 1 by 1 by 4. So obviously they have volume 4 each, and we have 53 of them, so 53 bricks can fill a volume of 53 times 4, which ends up being 212. So again, just like with the chess problem, you would think that you could fit a volume of 212 into 216, but it ends up not being the case. So now how do we figure this out? Well, the good thing is that if you were following the brain teaser roadmap, you'd know that in Quantipus number 15, we basically figured it out using the black and white square method, and we can just do the exact same thing, but in 3 dimensions here. So just to visualize that, I'm going to draw a few diagrams here. So here's what I ended up drawing. Basically, you have your view from above looking down into the box. You can tell because I drew these folds, that box is 10 to half. Then you have your side view where it's basically transparent so we can see into the box. So now to actually answer the question, can you fit 53 1 by 1 by 4 blocks in here? Well, if you did it out yourself and tried all the combinations, it's hard to visualize, but if you did that, you would find that you cannot do it. And the way we can prove that is in a similar way to the chessboard, but moved to a 3D setting. So essentially what you have to notice is that if I break this box up into a bunch of smaller 2 by 2 cubes, from the side view, you can visualize it, right? This would be one 2 by 2 cube, right? These right here. So how many of these can we fit in a 6 by 6 by 6 box? Well, you can see on the base layer, we can fit 9, obviously. And then there's going to be 3 2 by 2 layers going up, right? So we can fit 9 times 3, 27 of these 2 by 2 by 2 cubes. Now, once I understand that, I can use the same idea as the chessboard, and let's see what happens if we color them alternating shades of white and black. So now why did we do that? Well, you can see that if we take our 4 by 1 by 1 block and we place it anywhere within the box, then we know half of it is going to be in a white cube and the other half is going to be in a black cube, no matter what orientation we can possibly place it in, right? Like this one horizontally, same thing will be true. Even if we place it like this, it's true. Vertically, same thing, right? No matter where I place this, it's going to have half in white and half in black. Now also notice that we have an odd number of 2 by 2 by 2 cubes within this 6 by 6 by 6 box. And what that means is basically either I have to have 13 white cubes and 14 black cubes, or I'm going to have 14 black cubes and 13 white cubes. It doesn't actually matter. It's just based on the way you initially colored the cubes. In fact, in my example, I would have had 14 white cubes and 13 black cubes because the initial layer is going to have more white than black, so the top layer will as well. So for all these bricks, we previously showed that they have to have half their volume in a white cube and the other half in a black cube. Therefore, since I have 53 bricks, if I wanted to fill this box, I would have to have 106 units of volume in white and 106 units of volume in black. But since I only have 13 black cubes, that means I have 13 times 2 cubed, which is 8 units of volume in black, and that's going to be 104. So since I need 106 units to fill up 53 of these bricks, it's not going to work out. I only have 104. And that just proves that we cannot do this. So what's the answer of this question? It's no. Also, one quick side note, just note that we cannot use a method like this to actually prove a statement like this to be true. We can only use it to disprove the statement. For instance, say instead that it just worked out such that we had 28 2 by 2 by 2 cubes, and then this would have been 14 each, and we would have had greater numbers here than we had here. It does not necessarily mean that it would have worked, because in order to prove something is true, we would also have to find the optimal placement for these blocks, if you know what I mean.